Yes, it is possible for a warehouse complex tenant that wants two spaces and opens a wall between them to be served by two separate panels with two separate meters. Firstly, obtain approval. The tenant must first obtain approval from the warehouse complex management for the proposed modification. Secondly, install a new panel. A new electrical panel will need to be installed to serve the additional space. This panel should be connected to a different circuit breaker or transformer than the existing panel. Thirdly, separate the wiring. The electrical wiring for the new space must be separated from the wiring for the existing space. This includes wiring for lighting, outlets, and any equipment. Fourthly, install a new meter. A new meter must be installed to record the electrical consumption for the new space. This meter will be connected to the new electrical panel. Fifthly, separate the billing. The tenant will be billed separately for the electrical consumption of each space. There are benefits of separate panels and meters. One benefit is independent control. Separate panels and meters allow the tenant to control the electrical usage of each space independently. Another benefit is accurate billing. Separate meters ensure that the tenant is only billed for the electricity they use. Another benefit is safety. Having separate panels reduces the risk of electrical overload or fire in the event of a problem in one space affecting the other. However, there are considerations. Cost is one consideration. Installing a new panel and meter can be expensive. Maintenance is another consideration. Separate panels and meters require additional maintenance and inspection. The installation must comply with all applicable electrical codes and regulations. When considering the installation of separate electrical panels and meters in a warehouse complex for a tenant occupying multiple spaces, it's important to delve into the technical aspects to ensure a safe, efficient, and code-compliant system. Firstly, let's discuss the electrical load calculation. A thorough load calculation must be performed for each space to determine the appropriate size of the electrical panel and the service entrance. This calculation should take into account the anticipated lighting load, receptacle load, and any specific equipment that the tenant plans to use. The load calculation should be based on the requirements outlined in the National Electrical Code, specifically Article 220. This ensures that the electrical system can safely handle the expected demand. Secondly, consider the overcurrent protection. Each electrical panel must be equipped with appropriately sized circuit breakers or fuses to protect the wiring and equipment from overloads and short circuits. The overcurrent protection devices should be selected based on the ampacity of the conductors they are protecting, as specified in NEC Table 310.16. It's important to use circuit breakers or fuses that are listed and labeled for the intended application. Thirdly, think about grounding and bonding. Proper grounding and bonding are essential for electrical safety. The electrical panels must be properly grounded to the building's grounding electrode system, in accordance with NEC Article 250. All metallic enclosures, such as conduit and equipment housings, must be bonded together to create a low impedance path for fault current. This helps to minimize the risk of electric shock and ensures that overcurrent protection devices will operate properly in the event of a fault. Fourthly, focus on wiring methods. The electrical wiring for each space should be installed using approved wiring methods, such as rigid metal conduit, electrical metallic tubing, or cable assemblies. The wiring method should be selected based on the environmental conditions and the type of occupancy. All wiring must be installed in accordance with NEC Chapter 3, which covers wiring methods and materials. Fifthly, think about metering. The electrical meters used to measure the energy consumption of each space should be of a type approved by the local utility company. The meters should be installed in a readily accessible location and should be clearly labeled to identify the space they serve. It's important to coordinate with the utility company to ensure that the metering installation meets their requirements. Sixthly, there should be disconnects. Each electrical panel should have a readily accessible disconnect switch that can be used to de-energize the entire panel. The disconnect switch should be located in a convenient location and should be clearly labeled. This allows for safe maintenance and repair of the electrical system. Seventhly, concerning labeling and documentation, all electrical panels, circuits, and equipment should be clearly labeled to identify their purpose and function. A complete set of electrical drawings and documentation should be maintained on site, showing the layout of the electrical system, the size and type of conductors, and the location of all electrical equipment. This documentation is essential for troubleshooting and maintenance. Eighthly, about the electrical inspection. The electrical installation should be inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. The inspection should be performed before the electrical system is energized. Any deficiencies identified during the inspection should be corrected before the system is put into service. Ninthly, consider the coordination. Close coordination between the tenant, the warehouse complex management, the electrical contractor, and a utility company is essential for a successful installation. All parties should be involved in the planning and design process to ensure that the electrical system meets the tenant's needs and complies with all applicable requirements. Tenthly, consider the voltage drop. The voltage drop in the electrical wiring should be minimized to ensure that equipment operates properly. The NEC recommends limiting the voltage drop to no more than 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and should be taken into account when selecting the size of conductors. 11thly, think about the arc flash hazard. The potential for arc flash should be evaluated, and appropriate safety measures should be implemented to protect workers from the hazards of arc flash. This may include the use of arc-rated clothing, personal protective equipment, and safety procedures. An arc flash study should be performed to determine the potential arc flash hazard levels. 12thly, the emergency lighting is a critical factor. Emergency lighting should be provided in accordance with NEC Article 700 to ensure that occupants can safely evacuate the building in the event of a power outage. Emergency lighting should be powered by a backup power source, such as a generator or battery system. 13thly, power quality is critical. Power quality problems such as voltage sags, voltage swells, and harmonics can damage sensitive electronic equipment. Power quality monitoring and mitigation measures may be necessary to ensure that equipment operates reliably. The causes of the power quality issues will need to be found to find the problems. 14thly, surge protection is something to think about. Surge protection devices should be installed to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices should be installed at the service entrance and at individual pieces of equipment. 15thly, the future expansion has to be considered. The electrical system should be designed to accommodate future expansion. This may involve installing larger conduits and raceways, providing spare capacity in electrical panels, and planning for additional service capacity. 16thly, energy efficiency is important. Energy-efficient lighting, equipment, and control should be used to minimize energy consumption. This can save the tenant money on their electricity bills and reduce their environmental impact. 17thly, preventative maintenance is something to look at. A preventative maintenance program should be implemented to ensure that the electrical system operates reliably and safely. This program should include regular inspections, testing, and cleaning of electrical equipment. 18thly, training is a major point. The tenant's employees should be trained on the safe operation of the electrical system and on how to respond to electrical emergencies. This training should include topics such as electrical safety, lockout/tagout procedures, and first aid for electrical shock. 19thly, lockout/tagout. Lockout/tagout procedures should be implemented to prevent accidental energization of electrical equipment during maintenance and repair. These procedures should comply with OSHA regulations. 20thly, safety interlocks. Safety interlocks should be provided on equipment to prevent access to hazardous parts while the equipment is energized. These interlocks should be designed to fail safe in the event of a malfunction. 21st, arc fault circuit interrupters should be installed in accordance with NEC section 210.12 to protect against arc faults, which can cause fires. SI breakers are designed to detect arc faults and to energize the circuit before a fire can start. 22nd, ground fault circuit interrupters should be installed in accordance with NEC section 210.8 to protect against ground faults, which can cause electric shock. GFCIs are designed to detect ground faults and to energize the circuit before a person can be injured. 23rd, the harmonics should be mitigated. Harmonic currents can cause overheating of electrical equipment and can interfere with the operation of sensitive electronic equipment. Harmonic filters may be necessary to mitigate harmonic currents. 24th, power factor correction. Low power factor can increase energy consumption and can cause voltage drop. Power factor correction capacitors may be necessary to improve power factor. 25th, the reliability should be increased. Redundant power supplies and backup systems can be used to increase the reliability of critical equipment. This can ensure that equipment continues to operate even if there is a power outage or equipment failure. 26th, the remote monitoring should be there. Remote monitoring systems can be used to monitor the performance of electrical equipment and to detect potential problems before they cause a failure. This can improve the reliability and efficiency of the electrical system. 27th, consider the location of electrical equipment. Electrical equipment should be located in a clean, dry, and well-ventilated area. Equipment should be protected from physical damage and from exposure to corrosive substances. 28th, consider the coordination with other trades. The electrical installation should be coordinated with other trades, such as mechanical, plumbing, and fire protection, to ensure that there are no conflicts or interferences. 29th, sustainability is also something to think about. Sustainable electrical design practices should be implemented to minimize the environmental impact of the electrical system. This may include the use of renewable energy sources, energy-efficient equipment, and waste reduction strategies. 30th, security measures. Security measures should be implemented to protect the electrical system from vandalism and theft. This may include the use of locks, alarms, and surveillance cameras. 31st, documentation should be updated and maintained for future reference, showing the as-built conditions of the electrical system. This documentation should be kept in a safe and accessible location. 32nd, communication. Effective communication between all parties involved in the project is essential for a successful installation. This includes regular meetings, progress reports, and timely resolution of any issues that arise. 33rd, quality control. A quality control program should be implemented to ensure that the electrical installation meets all applicable requirements. This program should include regular inspections, testing, and documentation. 34th, change management. A change management process should be in place to manage any changes to the electrical design or installation. This process should ensure that all changes are properly documented and approved. 35th, risk management. A risk management plan should be developed to identify and mitigate potential risks associated with the electrical installation. This plan should include contingency plans for dealing with unexpected events. 36th, lessons learned. Lessons learned from previous electrical installations should be documented and used to improve future installations. This can help to avoid repeating mistakes and to ensure that best practices are followed. By carefully considering these technical aspects, you can ensure that the installation of separate electrical panels and meters in a warehouse complex is safe, efficient, and code compliant. This will provide the tenant with independent control over their electrical usage, accurate billing, and a reduced risk of electrical problems. Furthermore, the electrical codes and regulations will dictate many of the requirements for the electrical installation. For example, the National Electrical Code, or NEC, provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Local codes and regulations may also impose additional requirements. It is essential to consult with a qualified electrical contractor and to obtain all necessary permits before starting any electrical work. Additionally, consider the Americans with Disabilities Act, or ADA, which sets accessibility requirements for buildings and facilities. The ADA requires that electrical outlets, switches, and other controls be located within accessible reach ranges. The installation of separate electrical panels and meters should comply with the ADA requirements. In summary, the process of installing separate electrical panels and meters in a warehouse involves multiple steps, starting with obtaining approval from the warehouse management, installing a new electrical panel for the additional space, ensuring separate wiring, installing a new meter to track consumption, and setting up separate billing are all crucial. The benefits of this setup include independent control of electrical usage for each space, accurate billing based on actual consumption, and enhanced safety by reducing the risk of electrical overload or fire affecting multiple spaces. However, there are also considerations such as the cost of installing new panels and meters and the ongoing maintenance requirement. It's essential to comply with all applicable electrical codes and regulations throughout the process. By carefully considering these factors, warehouse complexes and tenants can ensure a safe, efficient, and code-compliant electrical system.